Today I'm going to take you through how to multiply and divide surds. Now when you multiply or divide surds, unlike adding or subtracting, the surds don't have to be like surds at all. Okay, so these in the box are the rules for multiplying and dividing. So if you have square root of x times square root of y, you can basically multiply x and y together under the square root. If you have something like this where there is a value in front of the square root, the values on the outside multiply and stay on the outside, and the values inside the square root can be multiplied and stay on the inside. This rule you would have seen before, so square rooting the top and the bottom is the same as square rooting the whole thing, and vice versa, and that applies to this as well. So you know, you can write a divided by b square root x divided by y, and it's the same as a square root x over b square root y. So let's use these rules to solve these problems here. So this is pretty straightforward. Basically all you have to do is multiply 7 and 5 together, and that gives us 7 times 5, 35. Now you don't have to show this step, I'm just showing it to you here. You can simply just go straight from here to there. And over here, I know that on the outside I've got 4 times 3, which is 12, and on the inside 2 times 3, which is 6, and that's the best I could do. I can't simplify root 6 any further. Over here I've got negative root 10 divided by root 2. Now remember, we can write this like a fraction. We can write it as minus square root of 10 divided by 2, okay, which equals to negative square root of 5, because this is simply just saying negative root 10 divided by root 2. Okay, so if you simplify it to that, you can actually see that you could just divide 10 by 2. For this one over here, we can first try and divide 12 by 3. That leaves us with 4 over 1, so we don't bother writing with the 1, and then we can divide the 18 by 3 to give us root 6, and that's our answer there. Now let's look at some more difficult problems. So these are binomials. So just like in algebra, whatever's sitting outside the bracket, you multiply into all the terms inside the bracket. So the first term, root 3 times 3 root 5, we have 3 on the outside, and inside we've got 3 times 5, which is 15. And minus square root of 3 times the square root of 6 is just the square root of 3 times 6, which is the square root of 18. And don't forget, if you can simplify, you should simplify. So we can simplify this one over here. So 3 root 15, we can't simplify root 15, but we can simplify root 18, because 18 can be split into 9 times 2, and the square root of 9 is 3, so that gives us with 3 root 15 minus 3 root 2, and that's the best that we can do for this one over here. For the next one, same thing. This term is going to be multiplied with every other term on the inside. So 3 times 2 is 6, and square root of 6 times square root of 10 is square root of 60, minus 3 times 4 is 12, and square root of 6 times the square root of 6 is the square root of 36. And obviously we can simplify these. We can simplify the 60 into 6 root 4 times 15. Now 4 times 15 is 60, so which means we can actually square root the 4 and take it out in a second. And over here, the square, whoops, that should be a minus sign. The square root of 36 is 6, so that's just basically saying 12 times 6. And then all you do here now is, well, the square root of 4 is 2, 2 times 6 is 12, root 15 minus 72. And that's as far as you can take it, because these are no longer like terms, or these are not like terms, and you can't simplify it. You can only add or subtract like terms, just like this one there.